Hey there, and welcome to today's deep dive. We are really glad you're here because our mission today is to completely shatter your traditional understanding of time.
Yeah, we were basically throwing the whole clock and calendar out the window today.
Totally. We aren't looking at, ticking hands on a wall. We're actually analyzing this really fascinating theoretical text called The Meaning of Time.
Right. And it's a text that redefines time as this very physical, highly variable, and honestly super malleable force.
It's wild. The foundational definition in this text, and this is what really hooked me, honestly, it states point blank that time is simply a recorder of the motion of matters.
Just a recorder.
Yeah, that's it. It arises entirely from motion, so no motion means absolutely no time.
Which is, I mean, it's a huge paradigm shift. It takes time from being this abstract, untouchable dimension and ties it intrinsically to the physical world.
Right. And the source makes some pretty wild claims, too. Like, it calls time antimatter.
Yeah, but not the sci-fi spaceship engine kind of antimatter.
Yeah. Exactly. It means time exists only in the material world. It's like the invisible shadow of physical matter. You can't have the object moving without its temporal shadow.
The text actually uses this brilliant analogy of a storm. It says, just as thunder and lightning only exist within the clouds, meaning if the sky is clear, there's no thunder time, only exists within moving matter.
Wow.
Yeah, in what the text calls the anti-world, or the negative universe, there is zero time, none at all. It just cannot exist without material motion to record.
That is mind-blowing. But even though it's tethered to the physical world, it is highly intangible.
Right, very intangible.
Like, the text is strict on this. We can't see it. We can't touch it or catch it. We definitely can't store it in a jar or borrow it from a bank. It can be described, but you can't depict it.
No physical shape whatsoever. But mathematically speaking, the source states the future is strictly positive and the past is strictly negative.
Positive and negative. Okay, let's unpack this. If time is strictly a recorder of motion, does that mean if you, like, freeze a wind-up toy mid-stride, time essentially pauses for that specific toy?
According to the mechanics of this source, yeah, absolutely.
Really? Just pauses?
Yes. Because time is embedded inside all moving matter, right? It spreads throughout the material space of the universe. So when the physical mechanism of that wind-up toy stops moving entirely, its internal, specific recording of time just halts.
Man, that's hard to wrap my head around. So since time is embedded in matter, let's look at how it affects everyday objects differently. We move from this universal concept of time to its specific application.
Right. The text argues time has both universal features, which apply to the whole, and specific features that apply to the individual object.
And it has this really great example for this, the pear analogy.
Oh, I love this one.
Yeah, so imagine you pick two perfectly mature pears from a tree. You leave one sitting out on the kitchen counter in the open air, and you put the other one right into the fridge.
Okay, pretty standard.
Right, then you wait 5 days. When you check on them, the open-air pear is totally rotten, but the fridge pear is still perfectly fresh.
Universally speaking, both pairs experienced 5 days, or, 120 hours.
Exactly. But specifically for the objects themselves, the open-air pear experienced significantly more than 24 hours in a single solar day.
What's fascinating here is how the text separates our human measurement of time from the object's actual experience of decay and preservation.
Yeah, because of its rapid internal motion and decay, the text suggests that open-air pear might have experienced like 28 or even 40 hours in a single day.
While the fridge pear experienced way less than 24 hours a day, maybe its day was only equivalent to one single hour of temporal recording.
Hold on, I gotta push back on this playfully for a second. Wait, is the fridge actually slowing down the fabric of time, or is it just, cold?
I mean, I know what you're thinking.
Yeah, because as a listener, you're probably thinking, guys, it's just a refrigerator. It slows down bacteria. That's biology, not time travel.
It is a crucial distinction, but the source insists we take this literally. It's fusing thermodynamics with literal temporality.
So it's literal.
Yes.
Okay.
Because time is the motion of matter, right? So slowing down the molecular and cellular motion of the pear using cold means you are literally decelerating its specific time.
Whoa, so the object's internal timeline is genuinely altered.
Exactly. The cold isn't just pausing biology. It's reducing the rate at which that pear generates and experiences time.
Okay, so if a fridge alters specific time by slowing down molecular motion through cold, What happens when we introduce massive macro-level motion?
Right, getting away from temperature and looking at pure velocity.
Because the text points out that our 24-hour day and our 60-minute hour, they're just conveniences.
Total artificial regulations. Humans created them based on the Earth and Moon's rotation, basically assuming we're all just standing perfectly still on the ground.
Right, but time is a variable, and the spaceship example really breaks this down. If you fly a spaceship east, moving with the rotation of the Earth, your day actually becomes less than 24 hours.
Yeah, the faster you fly, the less time you spend.
But if you fly west and you actually exceed Earth's rotation speed moving against the planetary grain, your day becomes more than 24 hours.
If we connect this to the bigger picture, the source gives this staggering hypothetical. Imagine your single day in that westbound spaceship stretches out to 240 hours.
240.
Yeah, that equates to 2,400 hours for the people down on Earth. And if you stay in this state of motion, you won't even feel time passing differently.
Right, your heart beats normally, your thoughts are normal.
But 50 years later, you return to Earth, step out of the ship, and find all your childhood friends are elderly with white hair.
Okay.
But you are still young and full of energy.
You essentially outran their timeline. And the author explicitly notes this is the literal physical root of concepts like New York time, Beijing time, and London time. They use location and motion to justify different times.
They aren't just time zone constructs. They are different temporal realities based on position and movement.
Think about it. Have you ever been on a long-haul flight and stepped off feeling completely detached from reality? Like you don't even know what year it is.
Oh, jet lag is the worst.
But according to the source, you weren't just jet-lagged. You literally were operating on a different timeline.
You were variable in motion.
Exactly. Okay, so motion changes time, but the source takes this a step further. It argues that the very physical makeup and environment of a person or object dictates their timeline.
Yes, moving from velocity to physical mass and environment.
Like time changes by zone. The text says the tropical zone differs from the frigid zone.
Right, which links back to the fridge analogy.
Yeah.
A person frozen in ice has unlimited time because their kinetic motion is zero. But a person in extreme heat has their time actively shortened.
It even says ocean time differs from mountain time. But let's talk about mass and volume because this rule blew my mind.
The mass rule is wild.
The text states, greater mass equals a longer life. This is why dense diamonds outlast wood or stones outlast clouds.
The incredible concentration of mass acts as an anchor.
But, and here's the catch, if two objects have the exact same mass, the one with the larger volume has less time.
Yes, because the matter is spread out more.
The text gives this very bizarre, specific example. It says 1 kilo of meat has less time than 1 kilo of stone. They weigh exactly the same. But the meat takes up more volume, so it burns through its specific time faster.
The underlying physics there is that density, that tight concentration of matter restrains the internal atomic motion. Spread out matter burns its temporal allowance faster.
Here's where it gets really interesting. It applies this logic to human beings.
Oh, a height thing.
Yes. For two people of the exact same weight, the taller person has less time.
Because their mass is distributed over a larger volume?
Right. Their internal material motion just burns through their time quicker. It's honestly hilarious. Next time you see your friends, you might want to subtly check their heights to see who is burning through their time faster.
I'm definitely going to be looking at tall people differently now.
Oh, for sure.
But, if the mass of a stone or the height of a human alters time, let's zoom out. What happens when we scale this logic up to entire planets?
The cosmic scales. This part is awesome. The text argues that different universe spaces have entirely different times. Earth time is completely different from moon time or sun time.
The numbers are pretty stark. It claims that an 80-year lifespan on Earth equates to only living to be 30 years old on the moon.
30? That's a huge drop.
Yeah, and it's entirely due to the planetary mass differences anchoring the specific time. The source even introduces these concepts of the 1,000-year world and the 10,000-year world.
I love those names.
A person who lives to be 100 on Earth could live 1,000 or even 30,000 years on those planets.
And it's not because of magic or alien tech. It's just gravity and mass. The source uses that ancient saying, 1 day in the heaven equals 1 year in the mortal world. But it explains it not as magic, but as a literal spatial difference. Heaven is just a high-mass planet.
This raises an important question, though. As we look toward humanity's future in space exploration, setting up colonies on the moon or Mars, Does this mean we will fundamentally fragment the human experience of time?
Wow. Yeah. We wouldn't just be separated by distance, we'd be living in entirely different rates of reality. A family on Earth and a family on Mars would have their fabric of existence completely out of sync.
Exactly. But, for right now, we can't easily change planets to extend our lives,
Sadly, no.
and we definitely can't change our height to alter our volume to mass ratio. But the source leaves us with one really powerful way we can actively control our own time right now on Earth.
Yes, the power of the slow walker. The text says time can be actively compressed or expanded based on our speed.
The higher your speed, the more compressed your time.
And the lower your speed, the more expanded it is. It uses this example called the two walkers. Two people are walking the exact same distance to a goal. The first one walks really fast or even runs. They reach the goal first, sure, but their time has been actively compressed.
They spent their temporal ledger to get that speed.
Right, they burn their gas tank, but the second person walks slowly, they stop, they turn around to pick up a gravel pebble, they touch the grass, they say hello to a bird, and they look up and say goodbye to a white cloud.
It's a very poetic image.
Very. They reach the goal much later, but their time has been expanded. So what does this all mean? I immediately thought of modern hustle culture.
Oh, absolutely.
Think about it. When you're rushing through your daily commute, sprinting up the stairs to get to a meeting early, we think we are saving time. But according to this text, we are literally compressing and losing our time.
The source emphasizes that true value comes from observation. That slow walker greeting the bird isn't just wasting time, they're literally stretching the fabric of their existence by interacting with the world. Efficiency is temporal compression. Lingering is temporal expansion.
Lingering is temporal expansion. I love that. Well, looking back at everything we've explored today, it's been a wild ride. We went from understanding time as an intangible recorder of motion to the rotting pear in the fridge.
We looked at the spaceship, altering its day.
We learned why diamonds outlast meat and why shorter people might outlive taller ones of the same weight.
And we scaled up to the 1,000-year world before coming back down to the slow walker touching the grass.
It's a reminder that time is a variable you interact with every single day.
It really is. And, if we strictly follow the mathematical rules of this source, it leaves us with one highly provocative, lingering thought.
Oh, right, the math.
Yeah, the text stated that the past is mathematically negative time, and the future is positive time. And time only exists when matter is in motion.
No motion, no time.
Right. So what happens at the very end of the universe?
Oh, man.
If all material motion eventually stops entirely, like maximum entropy, does the positive future and the negative past perfectly cancel each other out into zero? Does time just quietly vanish?
A completely zero-sum universe, the ultimate pause.
Yeah.
Wow. Just wow. So the next time you look at your watch, remember that measurement is just an illusion. You are a moving object generating your own specific time. Do yourself a favor today, go out, walk a little slower, say goodbye to a cloud, and expand your time.